Okay. So, good afternoon, everyone. So, today is the third live lecture for this NPTEL uh, course, Engineering Drawing and Computer Graphics. So, my name is Sanika, and I'm pursuing PhD from Indian Institute of Science, Bangalore. This course is being conducted by Professor Rajaram Lakkaraju from IIT Kharagpur, and today I will be conducting a live lecture based on the last week's lectures. So, last week lectures have been about construction of the conic sections. So, let us consider one conic section, which is a parabola. So, we can cover one construction today. If you want other constructions, we can do it maybe in the next sessions. So whenever I think of a parabola, I am reminded of the quadratic equation, and from that I get reminded of the coordinate geometry, in which we are always given a equation of parabola, which is a quadratic equation, and from it we are asked to find the directrix and focus. But I always wondered, who could look at the parabola and say, look, I'm defining a point here and a line here, and then the distance between the point on the parabola, the distance between the line and the distance between a given point is equal. Like, thinking out of the way like this is very difficult. Or who looked at the quadratic equation and realized that this represents a parabola. But after a while, I realized that it was it is actually the other way around. Parabola has been originally defined as the locus of points that is equidistant from a given point and a line. So, by definition, it is a locus of points that is equidistant from a given point and a line. And from this definition, we call the point as the focus and the line as the directrix. And from the same definition, when we introduce coordinate geometry, from that same definition, that the point A, which is on the parabola, is at equal distance from the directrix and the point x and y, which is the focus. So for uh, coordinate geometry, when you go, you first find the distance between the point A and F, and by simple distance method, x minus xf square plus y minus yf square, and root of that addition of squares. And distance between the point and the line, it is a little tedious, but because first you need to draw a line which is perpendicular to the directrix from the point A. Then uh, you need to find the intersection of the perpendicular line with the directrix. And when you get this point, then you go on and check the distance between this point A and the intersection point, let us say B, and equate it to finally get the equation, which comes out to be a quadratic equation. So this is how actually all of it goes. So let us try to construct the parabola on our own. So this is related to the first method of construction that has been covered in the lectures. So get one point. Let us say we are given the focus. One second, I'll just delete this. Let us say we are given the focus and the directrix. Now let us try to construct the parabola on our own. We'll get one point on the parabola very easily, that is the vertex. So if we know that if the point is on the parabola, it is at equal distance from the directrix and the focus. Now if we draw a perpendicular line from the focus here, this is perpendicular. The definition of parabola says that the point which lies on the parabola will be at equal distance from the directrix and the focus. So that would be actually the midpoint of this line. I'll name this as K, midpoint of the point KF, which is this, which we'll name as vertex V of the parabola. Now, how do we get the next points? So let us say, let us take a distance r in the rounder and draw a circle. So I'll draw a circle here. I hope my slides are visible. If anyone can confirm.
Yes, ma'am.
Okay. So let us say I'm drawing this circle here. What and the radius of this circle we'll assume it as r. We'll assume this is r. Now what is this circle? This circle is actually the locus of all points which is at distance r from the focus of our parabola. What I need to do next is have points which are also at a distance r from the directrix. What should I do? Should I go for drawing random circles? I'll just place my rounder here with r radius. I'll draw another circle maybe here and see where it intersects the previous circle. Will it work? It will not, because this distance would be r, but what we need is actually perpendicular distance between the points of the circle and the directrix. So okay, let us refine it a bit. I'll draw perpendiculars from all points of the circle. So I'll drop a perpendicular here and measure this distance from the point to the directrix, and keep on drawing perpendiculars until I get the distance r. But this is not practical. We cannot continue doing this for eternity. So what is the best thing to do here? What is a better thing to do here? What is the locus of all points that will be at same distance from the directrix? It is a parallel line. So instead of doing trial and error, drawing circles or drawing perpendiculars, we can simply have a line which is at distance r from the directrix and is parallel to the directrix. So this line is at distance r from the directrix, and uh, this circle is the locus of all points which is at distance r from the focus. So now here, this line that I drew in the last slide is the locus of all points which is at distance r from the directrix, and the circle is the locus of all points which is at distance r from the focus. So now the point which lies on both the circle and the line is at distance r from the directrix as well as the focus. So the intersection of this line and the circle is a point on the parabola. So this line that I drew parallel to directrix is what are the lines 1 1 dash 2 2 dash 3 3 dash that are being drawn in the construction in the lectures that you have seen. So uh, the 1 1 dash is the distance, is the line with distance c1 from the directrix. Line 2 2 dash, this line 2 2 dash is at distance c2 from the directrix. 3 3 dash is at distance cf from the directrix, and similarly all other lines. So now what is the next procedure? You take the distance 1 1 dash, this distance 1 1 dash, and you make an arc from the focus as the center and you intersect it with this line. So why are we actually taking 1 dash distance? When we saw in the previous slides, what we actually need is the distance between the directrix, this directrix AC, and yeah, sorry. So actually, what we need is distance from this line AC. So is it wrong? Instead of taking distance C1, we are taking 1 dash? No, it's not wrong. The initial construction that was done for this line BC was such that this line BC is actually at 45 degrees with line AC. And when a line is at 45 degrees with line AC, then the property is that the point B, its distance from line AC, that is its x coordinate, and the point B, its distance from line VC, that is the y coordinate, are equal. So when we are taking 1 dash, it is similar as taking distance C1. So that's why this method is correct. So even if you take C1, your method will not be wrong. Now the next step is, after you take this distance C1 or distance 1 dash in your rounder, you have to mark an arc placing your pointer at point F. So now here you need to be careful. When you have, let's say, distance C1 in the rounder and you are marking an arc from F, where should you mark the arc? That arc should be marked on the line which is at distance C1 from the AC. Why? Because when I'm marking the distance C1 from F, I'm saying that I am giving all the points which are at distance C1 from F. Since I want a parabola, I should intersect that circle with a line which is also at distance C1 from the directrix from the directrix here. So in case instead of this line 1 dash, you intersect the line 2 dash from F, what will happen is, now F, from F when we took, we had the distance C1. When you are marking it on the line 2 dash, wherever it gets marked, the distance from the directrix now becomes this, which is the distance of line 2 dash from the directrix AC. So this distance 2 dash from the directrix AC is actually C2, which is greater than C1. So if you see the eccentricity, which is the distance between the focus and this point, and divided by the distance between the directrix and this point, which is C1 by C2, it is less than 1. So instead of a parabola, you will be actually marking a point for the ellipse. And instead of maybe intersecting the arc with 1 dash, you instead intersect it with VB. Then your distance from the focus is C1. And your distance from the directrix is actually equal to VB or VC. So this VC is less than C1. And now what you get is actually uh, you get that C1 by VC is greater than 1. So it is a point actually on a hyperbola instead of on the parabola. So other constructions that are in this section are based on the Siner constructions, which are pretty much involved. And I think the construction part is quite easy for those things. So Anyone has questions regarding the construction for the parabola thing? Anyone has any questions from the assignments, any doubts? Okay, so has everyone understood all the constructions? Okay, so next time maybe I'll try to come back with the reasons why the next two constructions work well, like the rectangle method and the tangent method. Those are a bit involved, and I thought it would be a bit tedious to explain it in one class. Um, the so fine, if no one has any questions, I think we can stop the lecture. Did everyone understand what I tried to explain right now? The first construction of parabola method, the first method of constructing the parabola. Okay. So if no one has any questions, we can stop here. These lectures have actually been taken so that if you have any questions, we can discuss it. From next sessions, you can be ready with questions you have so that we can discuss it here.
रेकॉर्डेड व्हिडिओ बघत आहे तर सानू बाबा तुझा कुठल्या तरी एनपीटेलचा रेकॉर्डेड व्हिडिओ बघत आहे तर त्याच्यात मी बघितलं की पूर्ण म्हणजे बराच वेळ असे तो एक्सप्लेन करत असताना एक नोटिफिकेशन आली होती खालून आणि त्याला ओके किंवा डिनाय असं काहीतरी म्हणायचं होतं आणि तोवर ती स्क्रीन त्यांनी थोडी डार्क करून ठेवली होती तर ते दाबलं नाही म्हणून बऱ्याच वेळ ती स्क्रीन डार्कच राहिली होती तर बघ यावेळी पण असं काही होत नाहीये ना